Hello everyone, welcome to SchoolQuizz. So this side Anjali Singh, and again I'm back with the video. Okay, so in the previous video we studied about the balance as well as the unbalanced force. So in today's video we'll start with the Newton's laws of motion. So let's start with the sharing slides. Yes. So what about the Newton's laws of motion? As we already know that we completed force, effect of force, balance, and the unbalanced force. Now, Newton. Newton is a scientist. Actually, his name is Sir Isaac Newton. Sir means be honored, he honored as a sir. Okay, so he invented the laws of motion as well as the law of gravitation. Gravitation also we'll study in this class only. I think in the next chapter. So, Newton has given three laws to describe the motion of the body. He actually given three laws to describe the motion of a body. Okay, how the body is moving, what all conditions are applied when the body is moving. He established a relationship between the force applied on a body and the state of the motion acquired by it. Okay, how the motion is acquired by a body is actually explained by the Sir Isaac Newton. So let's start with the first law. So what first law is saying? Let's start. Some of the body, like any object around us, are actually at rest, means stationary. Some are moving also. So this law is basically related with the stationary object as well as the moving object. So I'm going to read the statement of the first law. If anybody is at rest, it will remain at rest. Okay, with the example like this pen, I keep it at rest, it will remain at rest. Okay, a cyclist started moving, so it will remain moving. Okay, and a body in motion will continue in motion. Okay, in a straight line with a uniform speed. In both the condition, either a body it is in rest, it will remain at rest. Either a body it is in motion, it will remain in the motion. Okay, unless an external force applied on it. बॉडी तब तक अपनी ही पोजीशन पे होगी जब तक कि हम उस पर कोई एक्सटर्नल फोर्स अप्लाइड नहीं करेंगे. This body will remain at rest until I applied an external force on it. Now see, I applied external force. So this body start moving because of external force, which is applied by me. Clear? With the help of brake, the body will come to at rest. Okay, the body will come to at rest. So this applying brake is an external force. Clear? This applying brake is known as the external force. Will change its position. Now, I'm going to read the statement. A body at rest will remain at rest, and a body in motion will remain in motion in a straight line with a uniform speed, unless it is compelled by an external force to change its state of rest or of uniform motion. Okay, unless an external force is applied on it. If applied, it changes its position. Okay, from rest to motion and from motion to rest. But what will be the condition? Condition will be to apply an external force. Okay, again, there are so many examples. Okay, the position of book, the position of cyclist, anything. So many examples in the universe, which is based on the Newton's law. That is why he considered as a great scientist. Okay, now after this, we'll move to the inertia. Tendency of a body to remain at rest or if moving to continue its moving in a straight line is called inertia. Inertia means, actually the meaning of inertia is to resist. Okay, inertia means to resist. Any body which is actually it is resisting to change its position. Suppose this body will be at rest, it will remain at rest. Okay, if I'm applying an external force on the body, so this object is resisting. Resisting means रोकना. Resist means रोकना. तो ये क्या करेगी? ये रुकेगी अपने आप को मोशन में आने से. ये ऑब्जेक्ट अपने आप को मोशन में आने से रुकेगा. लेकिन क्यों नहीं रुकेगा? Why it is not to stop themselves? Because my external force which I am applying, that is more than. Okay, if my external force is less, the object will remain at rest. This pen will remain at rest. Or if the body it is in motion, like the cyclist which is moving, suppose the cyclist is applying brake which has very less force, so it will not come to rest. इतना फोर्स लगाना होगा कि बॉडी जो रेजिस्ट कर रही है अपनी पोजीशन को छोड़ने से, अपनी पोजीशन को छोड़ने से हमें उससे ज्यादा फोर्स लगाना पड़ेगा, तभी बॉडी अपना पोजीशन चेंज करेगी. क्लियर? Inertia is that property of a body to which it resists the change. It resists the change. वो चेंज नहीं करेगी. अगर रेस्ट में है तो रेस्ट में रहना चाहेगी, अगर बॉडी मोशन में है तो वो मोशन में रहना चाहेगी. क्लियर? चेंज इट्स स्टेट ऑफ रेस्ट और ऑफ यूनिफॉर्म मोशन. क्लियर? Inertia means to resist its original position. Okay, either it is in state of rest or it is in state of motion. Greater the inertia of a body, greater will be the force required. Greater will be the inertia of the body, greater will be the force required. Clear? Due to which it resists a change. Oh, sorry. Greater the inertia of a body, greater will be the force required. Means if the mass, actually in inertia is the measurement of mass. If more is the mass of this pen, I have to apply more force to change its position. इस पेन का मास अभी कम है तो कम फोर्स में काम चल जाएगा और ये अपनी स्टेशनरी पोजीशन को तुरंत छोड़ देगा और मूविंग पोजीशन पे आ जाएगा. और अगर मूव कर रहा है तो मैं एक्सटर्नल फोर्स दूंगी तो ये तुरंत स्टेशनरी पोजीशन में आ जाएगा. लेकिन in place of pen, if I'll keep this king size bed, so greater is the mass. Like the mass of this king size bed is more, it means more force has to be applied. Okay, it means more force has to be applied to change its original position. Either will be in rest or it will be in motion. So the meaning of inertia first is to resist its original position. Second, measurement of inertia is more will be the mass, then more will be the inertia. Less will be the mass, then less will be the inertia. Clear? Here it is written like, yeah, heavier object have more inertia than the lighter object. If anyone will ask you, which one is exerting more inertia, like scooter or a bus? Definitely bus, because it has more mass. It means it has more inertia, directly proportional relationship. More mass, more inertia. Less mass, less inertia. Clear, everyone? Now, for example, a stone has greater inertia than a football. Yes, one another example means the inertia of a football is greater than the stone. Okay, if we kick a stone, it will not move because of its high inertia. Stone will not move. But if we will kick a football, it is easily move. Okay, it is easily move. Now, like this, yeah. A cricket ball has more inertia than a rubber ball. Again, same. A stone has more inertia than a football. Okay. Inertia of a body depend on its mass. See, the boy who is pushing a small car, means toy car, is very easy. And to push a real life car, means original car, is more tough because the mass of this car, means second picture car, is greater than the mass of first picture car. Okay, it means it has to apply more external force. Okay, it means it has more inertia. From after this whole discussion, what will be the conclusion? To overcome the inertia and make a body move from rest, you must apply an external force. Definitely external force will be applied to leave its original position. Either it was the position of rest or it was the position of motion. Now, next is, that example is very important. Mostly it is coming in exam. The coin experiment, that is that is the first law of motion. Like you can see this coin in the first diagram, figure 14. Coin which was placed on the cardboard, glass tumbler, force act on card only. Now you are acting a force. Please do this example. It's very easy and interesting also. Maybe you uh, you did also, but now you know the concept behind it. So when you will apply the force on the cardboard, so what will happen? The cardboard will only move. The coin will remain in its own position and the coin will drop on the glass. The coin will drop on the glass. Yes. The force of our flick, however, does not act on the coin, so that the coin continue to be in state of rest due to the inertia. Here, what is the reason behind it? The reason is inertia. Here, which type? Actually, the inertia is of three types. The first is inertia of rest. Second is inertia of motion. Third is inertia of direction. Here, which type of inertia? Inertia of rest. Because the coin will remain at rest. Clear? Please read it by your own also. We'll consider the second part of the first law of motion, which says that the body in uniform motion will continue to move unless a force compels it to change its state of uniform motion in a straight line. Means the body will remain in its motion unless we apply a force which comes to the object to be at rest. There are so many examples. The first example is this photograph show a person sitting in a car wearing a seat belt. Seat belt are provided in the car so that if a car stops suddenly due to the emergency brake, sometimes a driver should apply a emergency brake. So due to this, car should come to rest position. Okay. So because of this sudden apply of brake, the car will be in motion, but the man will be in rest. Here you can see in the diagram, the man will be at rest. So because of the inertia of motion, a driver, or you can say the person which is sitting in the car, that will accidentally fall on upward direction. Okay, it falls on upward direction. To avoid this, the man which is inside the car is wearing a seat belt. Okay, the car stops suddenly due to emergency brake. Then the driver and the passenger are not thrown forward violently. Okay, not thrown forward because of the seat belt. Otherwise, when any object will start suddenly, the person should move backward. When anything, like any vehicle, when you are in train or you are in bus, when the bus start, okay, suddenly, so what will happen? You will move backward because you are in rest. Okay, when the vehicle, any vehicle will will comes to rest. So what will happen? We will move forward. Please keep in mind, when we will move forward, when the vehicle should be stop. Okay, suddenly stop. When we will move backward, when the vehicle should start. Okay, when the vehicle should start. Clear? So when a car or a bus turns corner sharply, we tends to fall sideways. Okay, when a bus is turning, definitely we are also turning in the direction of bus. This shows the inertia of direction. The second example of seat belt is showing the inertia of motion, and this example is showing the inertia of direction. So this is the case. Okay, so please read it by your own. So this is the case of Newton's first law as well as the inertia. Okay, in the inertia also, we studied about the inertia of rest, inertia of motion, as well as the inertia of direction. So please read this topic, which is the inertia, which is the Newton's first law of motion. So till that, stay healthy and stay safe.